morning, everybody. My name is David Cuthbertson. Unfortunately, I can't speak Romanian. I'm typically English, so we don't understand other languages. So if there are any questions, or if I talk too quickly, please stop me, and Mihai or Alec will try and help and assist with any questions or any communications. When I was preparing this, I thought I would just check and see what's been happening last week. And as you can see, there are various issues. If you thought the experts who to run your networks and systems, like IBM, Dimension Data, CSC, Fujitsu, Tata, well, they've been hacked for many years. And yet, a lot of organizations outsource to them to manage not just the technologies, but also their security operations centers. And you look through others, NASA, there's been something there for 2 years, sitting on their network. They've just discovered it. And so the issue we have with cybersecurity is that you can't have security if you don't change the way that people work, if they don't respect it. Now, I was talking to somebody earlier about controls and governance. How do you trust that your system is secure if you don't trust the people, because you can't see process, you can't see predictability? And so I have my own little part of the world of IT. It's a very big part, because as we all know, security is still ignored by lots of IT organizations at the moment. Some of you may have heard of Norsk Hydro, make aluminium. They were hacked last week. They are not going to pay the hackers. They reckon it's going to be somewhere about 45 million euros to actually fix things, but they're not going to pay the hackers. So they have an aluminium plant where they had to go back to people. And next week there'll be some more. And next week there'll be some more. In America, 2 of the cities in Florida last week announced they're going to be paying $600,000, $500,000 to ransomware. Baltimore, they reckon it's probably going to be $18 million. That's what the ransomware demand is at the moment. And the FBI are investigating. This is every day. Why does it happen? Don't people trust security? Don't they trust their IT people? So, to introduce myself, I run 2 companies in England, and we've been going about 14 or 15 years. And I had previously run an outsourcing company. I used to run voice and data networks for financial institutions. My core focus was a network troubleshooter. Who do you call when Cisco can't fix the problem? Or it's a combination of cabling and applications. And I sold that business and another one that built networks and data centers. And then I said, if I'm going to have a business, what will keep me going forever? And the definition of any good business is you've got skills that people don't have, and you're doing something they don't want to do. And so I decided IT documentation was perfect, because nobody in IT likes doing it, so they don't know how to do it, and scale becomes a problem. So that's the core of what we really do, which is helping people understand their environments. And there doesn't seem to be anybody else anywhere. And so I hope that today you'll get an idea of some of our methods and practices, so that then you can adopt them yourself. The reason I have 2 companies, AssetGen is our software company, where we develop software, some of it we give away, and Square Mile is our services company, where we help people understand where do you start, because most people already have an existing infrastructure. It's not that it's new, it's that we've already got something, and we have to make it better. The technology we developed, the AssetGen infrastructure database, our core business, we've been selling it now for about 14 years. It goes through various versions. If anybody here uses Microsoft Visio software for doing diagrams, we develop and give away free Visio utilities for data centers, networks, services. And if anybody has time this afternoon after lunch, I'm going to be running a more technical workshop. If anybody that wants to know is, how do you automate Visio diagrams? Okay, because Visio is a very useful way of presenting how things work, dependencies. But how do you do 1,000 diagrams? How do you do 10,000? And so I've got 2 big projects at the moment. One is for British Telecom. We're doing their mobile phone network. So it's 85 data centers and 6,500 racks of equipment. And so every night we present 6,500 Visio diagrams of all the racks and what's currently in them automatically. But we're also doing all of the cabling, all of the power, all of the rooms. and that's the first phase of the project. Another project, 2 weeks ago, I was in New York City. We're doing the schools. So we've got 2,000 campus environments and 5 data centers, and they're refreshing all the physical infrastructure, all the cabling, all the networks, all the wireless, all the security systems. How big a spreadsheet is 2,000 schools worth of information? How do you maintain it? How do you even get that spreadsheet to start with in an efficient way? So a lot of this is about scale, and how do you organize things? So it's not just security that uses it, but it's also other things. A lot of my focus really is about best practice frameworks. Anybody who here are familiar with the ITIL framework, or ITIL? Anybody heard of that? Service management? Yeah. Part of how I got into this was I used to run the ITIL group for the British Computer Society. And my speciality is configuration management. So I know a lot about services and service management and the control of change. But because I also built data centers, I also understand that ITIL doesn't carry everything. And so a lot of my work is nowadays with organizations covering things. Has anybody here heard of BICSI or BICSI? Tomorrow there's a meeting in, I think it's the Hilton Hotel that I'm presenting at, the BICSI Romanian chapter, and I'm presenting all about how do you manage connectivity across multiple sites. So how do I centralize control and planning to be able to manage distributed infrastructure down into cabling level. And there's other presenters talking about other things as well. But I do a lot of work with BICSI because they're an American trade body, but they focus on infrastructure, which is really where my focus is. But it means I get involved with lots of different things. I'm going to talk a little bit about the NIST cybersecurity framework. Anybody familiar with the NIST framework? A couple? Which came out from America a couple of years ago. It's just useful. There's lots of cybersecurity frameworks, but it's a useful one because it takes a slightly bigger picture and often helps explain the complexity of what we're doing. And you can see there's lots of different organizations. Over the last 14 years that we've been working with our software and our systems, we've been around lots of places. More recent customers are Microsoft. So I teach Microsoft data center people how to use Visio. They make it, but they don't know how to apply it, because it's not the tool that's the problem, it's the method, it's how you use it in the process. But likewise, we also work with various military organizations. Our software is used by the US Cyber Security organization that handles all their forensics, based in Baltimore. A lot of it is not about, you could say, me knowing a lot about the customer. We give them the tools, but the data is very sensitive. Our longest standing customer, just hidden in there, is MasterCard. They have used our software for about 12 years now, and every single piece of equipment and every power and data cable worldwide in MasterCard is in our software. So they can plan in St. Louis in Missouri any changes to any physical infrastructure, and they can have a consistent way of implementing their policies worldwide. But there's one team that does it everywhere. So if I need something in my data center in Singapore, they plan it. If I need it in Brussels, they plan it. They have local knowledge brought back centrally, and then they use third parties to build things. But they keep control through the planning and the change that involved in any changes. But it doesn't matter, any organizations. New York City, the education department was the second project. The first one was their emergency services to handle all fire, ambulance, police, the whole of New York City. So that's us. A couple of things to start with, and the first of which is this isn't really about technology. It's about how you manage technology. There's always going to be new boxes, new bits of software, new frameworks, but a lot of this is about things. And the first one there is first of all, it's the whole culture of IT. They don't like documenting things, which is why I do my business, but that's not the only issue. They also don't necessarily have a good understanding of how to communicate and to handle politics within an organisation. It's a very general term, but talk to any auditor and ask what their biggest issues are. Communication. So security in any form of risk management is seen as an inconvenience. Why do we have to change our passwords? Because what if we've already been hacked? Yeah, but we don't know we've been hacked. I don't like changing passwords, I forget. Okay, but it's a good thing to do, because if somebody's already in, you should do it. Why don't you check your backups? Well, it's a bit inconvenient. I've got other things to do. And so this is really where you have to then say, you have to have some level of authority to assert yourself to do what is best practice. What do others do to handle all of this? Modern IT practices, we don't use the same people. We can't get the skills in one person. We have to make use of partners. We have to outsource. I am having a lot of work now coming through the adoption of cloud infrastructures, where people have no data center, no services. It's all run on somebody else's systems. They have no idea how those other people run and manage their networks. They have no idea who has access into them. And that's where we keep saying, but didn't you expect them to do this? Didn't you realize they don't actually change their own passwords themselves? And people are starting to see that any form of outsourcing to a third party of your core infrastructure and the data, you should know. The trouble is, you have to be more expert than them to understand what they're not telling you. But that's why we need frameworks and we need auditors and some structure so that then you can assess the risks. But essentially, you still need to go and get the skills from somewhere. A simple one there, my starting point for lots of people is they don't even know what they have. It's not actually very easy because you have lots of different teams. But if you don't know what you have, how do you know you're monitoring everything? How do you know you have software licenses for everything? Actually, there's a lot of things that mean we really should have this. You know, how much should we spend? Actually, we should really know this, but you try doing this in practice in any organisation, or where you have combined organisations together. So it limits the effectiveness of your controls if you don't have a good starting point. And as a result of that, I spend a lot of time listening, talking with customers. We often don't see our system. I've never seen MasterCard's database that we gave them because it's very sensitive. It's got all the IP addresses. It's the best tool for any hacker because it shows where everything works. But if they didn't have it, then how do you protect yourself? You need to know what you have. So that's the starting point. Does anybody disagree with this? No? It's not about technology, it's about how you manage technology. And change can cause more disruption than cyber attacks. So this is just a very quick overview of good things you should do, and this came from the UK government, it's one of the many sponsored things. And what you should do all sorts of things. You probably can't read all of this right from the back. But basically, the whole point is you should protect yourself against malware, you should remove rights and permissions. But I've circled some in red here, the things, and to make it a bit easier to read, the next slide just summarises them. You should have some form of network perimeter. But that means if you don't have one at the moment, you have to change things. You probably should monitor systems and applications, but they may not be set up to be monitored. And monitoring means we have to open up firewalls. So actually we've got to change things to even start implementing these. We should make sure we update patches where there are known vulnerabilities. The trouble is, it's a change. And some changes cause disruption. And so a lot of people don't like patching their systems because it causes problems. And so you start getting to this issue where actually, if the reason for having security is to provide consistent access to data for users, actually updating patches is actually causing problems. It's causing the problems you wanted to avoid with security. So a lot of this is about managing change. So all of these things, controlling user access, segregating, partitioning networks to try and reduce domains. You have to make a change. You have to change the network, you have to change rights and permissions. Actually, change is a problem. I'm not sure how you find it, but certainly in the UK and in other places, over 90% of disruption is caused by change issues. Somebody upgraded the software, didn't realise the impact. Somebody went from this server platform to that server platform, didn't realise there was other software on that platform. So they found it when they migrated. It's the reason why, to minimise risks, good practice is to set up a production environment where you control things very carefully, and then you have separate test environments and development environments and disaster recovery environments. That's good practice, isn't it? But what if you don't even understand how your production environment works? You can't have confidence in your DR. Security requires you to have the ability to recover, at least up to a certain point, to recover the data, maybe even the systems. So, if we're going to have good security, does that mean we have to solve all these other problems? And the answer is yes. But you can't do it all. You've got to have focus behind the audit. And if we're going to start partitioning where we're going to do, we might have physical separation, buildings, rooms, cables, but of course it's inconvenient because anything physical takes a long time to do. So we often do it now logically. We'll have virtual networks, virtual systems, which is all fine when everything's working. When the operating system hasn't been hacked, when this has been hacked, when your management system, and we've seen some of the early software-defined networks run into real problems because of mismatches with firmware on devices. They couldn't run the management software properly, so the networks crashed. But this was supposed to be super resilient. There was no cable to pull. We couldn't log into the device. So you have to assess and understand what's the best way in terms of the way you separate and you minimize some of the risks and the issues. So, good thing here is about approach. How do we actually get started? So, it's not the only thing. If you have demotivated people, you're making them redundant, you're outsourcing them, are they going to do all the things you want them to do? Are they going to find a way to get back at you? And so, that's why the insider threat, where there may be an ideology or a personal interest, is a problem. But also we have limited resources, and our partners, well, we have to often use people with skills. Are they helping us? There's a whole range of things. So the big issue here is confusion. And every time I go and talk to people, I say, what problem are you trying to solve? And they go, everything. Security doesn't stand alone. It's just part of the way we manage. It's a factor, but actually also we have limited budget and we have a job to do every day as part of this. And things keep going wrong. People keep cutting wires. We keep using power at the wrong time. We keep finding a backup doesn't work, only when we try using it. So various things have all happened, and what sort of affected us and got us more into the security side, the security is just one of the things you need to do, is how you actually understand things. This is just a simple little issue. So here's a very simple diagram, which you can all see there. I have a power strip, I've got a management tool, so I can get access to the servers there. And what happens if we drop the power to the circuit? Okay. If we drop the power to the power breaker, we're going to lose those devices. Do you all agree? Okay. So that's the risk. But if I give you more information, so let's just say we have some resilient power. It's different now, isn't it? So what you didn't know will change the way you think. And of course, when you start looking at this diagram, you start noticing inconsistencies. So we start to see that this server has two power connections, but it doesn't have one to here. Is that a design or is that a fault? Okay. We also start to see that we have network connectivity. So if we lost this, we lose the network switch. So even if the servers are still working, they can't communicate to anything because they don't have a network connection. So actually, now when you start thinking about change, this diagram is very useful, isn't it? But I might change the switch because I'm going to upgrade my network. I might change the out-of-band management. So we have a separate control plane and management plane for our data. I might change the power infrastructure because we have to keep balancing phases. And I'm going to change the servers as well at some stage. How many servers are there? Only a few. Some racks you can't mix, you've got to know what they are. It's not simple. And so this is why we have to actually start saying is our biggest problem is how we manage complexity. So the more information you have, the better able you are. Of course, if something gets attacked, we need to have this available to us. We don't really have to reverse engineer this while we're in the middle of an attack. There's another view of the same servers. Those servers that were there, I showed you the physical connections, but somewhere in there, that's where those servers are, that's what they do. There's a different view, it's a more logical view. And in this case, if we have some desktops that are affected by ransomware, to know where they are and what they're doing in the context of other systems and applications helps us isolate what's likely to be a problem. What do we have to go and look at? So yet again, same servers, different view. And this is the problem of the complexity of IT systems. It's difficult to understand. You have to work at it. And this is why I'm in business. And a lot of these methods is not difficult. Well, not to me. It's actually just about, in a sense, keeping it as simple as you can. Okay? But also understanding that you do have to work at it as well. So, in 2014, the US National Institute of Science and Technology produced a framework because what was happening is lots of different organizations were coming up with their own, what's supposed to describe it, view of what security and cybersecurity was. And so the NIST framework came about by saying is there's lots of good information, but why don't we just bring it all together rather than just build another framework? Why not just point you and say, this is good, and all these different frameworks cover this, the detail's already there. And it came out in 2014. The first major project involved in that was the state of Hawaii, where they'd had a number of hacking problems, and they had lots of reports and lots of consultants, and everybody said, what do we actually have to do? I've got all these different reports. And so what we needed was a way of structuring that. So they employed the ex-CIO of the FBI. Interesting enough, he was Muslim, and he comes from Afghanistan. You wouldn't think of that, but actually anything can happen in America. And so originally he was the son of an Afghan farmer, and they immigrated, and he then became the CIO of the FBI. He then went on to head up cyber warfare with one of their contractors. But this guy, Zal Azmi, was asked to come in because he knew a lot about cyber security. As you can imagine, he helped write some of the NIST framework. And he then said, the biggest problem, as you'll see, is actually the starting point. How do you start? So I'll just explain a little bit about the framework. It's free, you can download it. There's lots of information and presentations. But you'll see, it's just trying to take a practical perspective of things. The first thing is that they said, well, let's try and break this down into 5 different areas. How we identify what we have and what's important to us. How we then go through how we protect, how we detect, respond and recover. So 5 sections. It's all written down, guys can download it. You can even get it down in an Excel spreadsheet. So you can then start putting red and greens, yes we're good at that and bad at this. And it's been now adopted in England, in the US, it's been sort of taken up by a lot of federal agencies, but also commercial organizations as well. The framework splits itself down into greater detail, and in the identify section, you might just read this at the back, it covers things like knowing what you have, knowing your environment, what's important, understanding risks, working out priorities. So before you even start, because once we have that, we can then start looking at how we're going to start protecting things. How do we change our access control arrangements? How do we do training? How do we do information protection? How do we partition things? And if we break down a little further, this is why we got involved with Hawaii, was the first section there, asset management, says really, you should really understand your physical environment, your buildings, your rooms, your wireless, data centers, everything like that. That's one starting point. You should understand what software you have. That's easy, isn't it? If you don't understand what you have physically, obviously it's very difficult to work out what you have software-wise that sits on it. And then, even worse, start understanding how communications and data flows between systems. But this is what you should try and do. But trying to do it isn't easy, because you start realizing, who would know any of this? No one. The network team know the network, the server team know the servers, the application team know the applications. Try doing GDPR. And it says, well, where is user data? It's a big problem. Wait a minute, you've got basic issues to sort out. If you had sorted this out, it would make it easier for GDPR. So there's a lot to do there, so I'll just split those out. This is only the starting point. Okay? So let's take the physical inventory, and then in a bit more level of detail, there are these various standards that we use as the basis for the NIST framework. And so COBIT is used for information assurance, because it's already published, it's already in use for financial information sets. But there's also ISO 27001, there's also industrial automation, and there's an internal American one for federal agencies. And what they did is say, just look at some of those, they just overlap, they all say the same thing. So if you do one, you probably do the other. And just as an example of a bit more detail, so for instance, in just this area, asset management, the security standard at the top there says assets maintained in inventory should be owned. Who's the owner of this system? You need to know we've got them first, and then say who's the owner. But is that the technical owner or the business owner? Because we may outsource to third parties to actually run and manage this for us, or to be able to do patch management and other things. What about this? Assets associated with information processing should be identified, and an inventory of these assets should be drawn up and maintained. That's almost the same as the first one. Slightly different flavour and things. Because here we're actually starting to talk about what the assets are used for. Here we have authorised hardware. Well, that assumes you know what's on the network already, and you can identify what wasn't authorised. So actually it's a slightly different view of the same thing, which is why in this framework, you can see why people are confused. You can have different people saying this standard is the one we should use, and somebody saying this standard, but they all overlap. So in this framework just said, they're all roughly the same thing, but you work out what's important to yourself. Inventory, maintain and assets, yeah, so COVID has its view, but then it's slightly different to these. And then with this one here, accurate configurations are contained in the centralized database with detection of unauthorized things. It'd be nice to have a list of assets, wouldn't it? Depending on what the term is. But actually, unfortunately, that's not good enough. So before you think this is impossible to do, no, let's actually look a little bit further. What do we actually have to do? So, in summary, it's nice to know, in fact, it's really important, because you can't secure your environment if you don't have this as a basic starting point. But start looking at simple questions. What do you have? Where is it? What does it do? Who uses it? Who can change it? Who can get access to it? In the old days, you used to lock the data center, and once you were past the front door, you could go anywhere. More recently, you're now locking every individual room. Now you're going into every individual cabinet, and each cabinet has a unique lock and a key. It's very inconvenient for IT people. Why do people make it so inconvenient? Because they can't trust people. And actually, the work we're doing at British Telecom, the first thing we do when we go onto a site, my contractors have to draw up a list of every single cabinet we're going to be working in, and produce a list of keys, and give it to the security guard and say, these are all the keys we need. We're the only people that's ever done that. Normally what happens is people arrive on site, BT engineers, and they get access into the data center, and they walk around all the cabinets, work out where people are, where the things are they're doing, and they write down the names of the cabinets, they come back, and then they forget they should have the key number, so they go back, then eventually it takes an hour before they can even start. But we just wrote down the list to start with, but we did it consistently, so now we can work in any areas. So people ask us how to get into their cabinets. It's just because we have a small amount of information. This is where we start getting into a lot of difficulty, is where we start understanding dependencies. If I change this, what's the impact? What's the impact on a contract? What's the impact on data? What's the impact on users? What's the impact on our disaster recovery policy? If we start outsourcing things to the cloud, so we're running on Amazon, what if Amazon has a problem? How do we do recovery? We can't, only they can. But they don't answer the phone when we have problems. Wait a minute, there's something wrong here. How do you move from one outsourced provider to another? How do you move from one cloud infrastructure to another? And the answer is, we didn't think about that. But actually, didn't your security people have a view on this? Wasn't there an assessment of the organizations you're working with? And there's many other things that we have. But the thing is, to do this on a scale, we have to start thinking, actually, they don't know how to do this. So you can't blame people for not doing it. You just say, actually, it's not simple. It's complex. So, this is my view, to give you an idea. The thing is, I'm paid to give this view, and I travel a lot, because actually they can't find anybody else. The reason I go to America is there's no one in America who you can find. But I've been to Saudi Arabia, and Alec was a customer for many years, because there was nobody in Saudi Arabia. But actually, a lot of this is about common sense. So you don't have to buy anything, you just have to make sure that you have clear understanding and you can communicate it. So the first thing is, that may be the current starting point. The nice thing about cabling and racks is it shows dependencies that are out of control. It would have been nicer if it is nice and neat and tidy, because if I change any of that, I could cause a problem. If I have to move anything, it's going to probably cause a problem. There's no labels on any of the cables, so I don't know for certainty what I'm changing. But that's how you may have to start, because you may have to say that that's a security problem. You could patch anything in there and nobody would know. Ask NASA why a Raspberry Pi was on their network and nobody realized it. Because it's probably like that. But what we do is we simplify things. So we'll probably break this down into probably 3 sets of information. This is just physical to start with. And so I'll want to know where things are. So I'll do a space diagram. I'll do a schematic. That's why Microsoft Visio is often used. But you may do this in CAD, you may do it in a spreadsheet. Whichever is the most convenient way to show where things are, because then I can see where I've got space. I can use it for planning, and people can find things. I'll probably produce some form of structure to list everything that's in there, with operating systems, make, model, ownership. That's a good start. The trouble is, it doesn't work very well when you have complex devices that have lots of things in them. Modular cabling, blade servers. So it's okay if it's just one thing, but not if there's lots. And I'll probably have something that then describes all of those wires. Most people have difficulty doing this, but if you don't have this, you can't have that. And in my experience, often these don't agree with each other. So we have lots of devices in our data center, but we have no records of their cabling, but there's cables in them. There was a gap in process. And so you then start realizing, to understand, you need more than just one system. You need lots of different perspectives. I'll take this a little bit further. So we've simplified that to make it easy for anybody. So let's go a little bit further. We're going to end up, probably, with every project, you should really have a project document. This is what we did, this is where we put it, this is how we connected. It's available. It's part of handing over between design, build, and operations. And if you don't have this, you should look to get this. The trouble is, you end up with thousands of them. With British Telecom, they had 6,500 rank diagrams in Microsoft Excel. Okay? Which is good, because then they have a reference. But they version control them. And if you've been doing it for 10 years, you may have 50 to 100 versions of 6,500. So how many Excel spreadsheets do we now have? And of course, what are you going to do with them? You're going to include them in your project plans and build documents, so you're going to be emailing them backwards and forwards for those 50 to 100 times you make changes. You start to see how it multiplies. It doesn't need 6,500 racks, it could only have 100. And you start to realize, I don't know where things are, and I don't know what the latest version is. But if we just look at this diagram, here we have one device, and there's 2 versions of a server. There's a physical view, and there's a logical view. On the physical side, we'll probably take commercial information. Security, patching, inventory, cost, promotion. Suits to a spreadsheet. Often we'll have an asset management system focused around the financial controls of the environment. But when we start saying, well, let's look at the physical side of that server. So where is it? Well, where is it in the room? Was it in the rack? Where is it on the floor? How is it cabled up? Its physical cabling, or its power, or its build, which modules go in. And you start realizing, actually, it doesn't suit a spreadsheet so much. A floor plan is best done in a CAD or a Visio package. A rack diagram can be done in Excel. But what starts happening is, as you go to the right, you then start finding that you start moving from lists and database type approaches, and you start wanting to have pictures or schematics. So the best way to describe a network is with a picture. So if anybody wants to see how to do this in practice, this afternoon I'll be showing you how you can take an Excel spreadsheet and use it to help you with a network diagram quickly, instead of typing everything. But that same server isn't just in a network diagram, we've got a storage diagram, we have a data flow diagram, we have what virtual machines are running on the server, we have remote access, production environment, testing diagrams. And we may then get to the business side, where we don't require about the technical side, we want architecture maps. We want to be able to understand the roles and responsibilities. How many diagram types are there, do you think? I gave up when I came up with 600 different styles or types of diagrams which people maintain in IT. Because I was realizing it's a big problem. There's a lot of whiteboards used in IT environments, A lot of people now, I'm not sure about yourselves, but I was in a Dutch bank a few weeks ago, and they have put plastic film on all their walls in their IT department so they can write on the walls because there isn't enough whiteboards and they need the space. And the cleaners are not allowed to clean the walls. But there's no version control on it. But the reason they had it is because actually it's useful, it helps. And the same also in England we have a term, you may have it here, called a war room. If you have a major incident, you have an area that everybody goes to that's preset for managing major incidents. And I've been in the Lloyds Bank war room, the Barclays Bank war room, various government agency war rooms. And they're all set in the same way. There's lots of phones, lots of power for everybody's laptops, and then plastered all over the walls is all the documentation so you don't have to print it out as much as possible. Lots of architecture maps, how our phone system works, how our call centres work, how we pay bills, how people supply information to us. So it has to be there. But you look at the dates, 2003, last updated. Where is the original? That server doesn't exist anymore. Where's it now? Right, why have you still got it here? Because things haven't changed that much, and it's useful. Its speed is important. You can imagine with a cybersecurity incident, how much time do you have from detection? And the answer is, actually you were probably broken, or somebody got something in a long time ago. So you're reacting to something that's just suddenly been kicked off. They probably know more about your systems. I know how to understand networks, that's what my job used to be. But we have to take the view that it's not just a big database we need, or it's more spreadsheets. It's a bit more complex than that. And actually, it's not the job of the security department to do this. They should be reusing the information that people use normally day to day, because otherwise you can't trust it. It's the day-to-day work that's important. And there's just a few types of diagrams that you have. Well, there's another list here. But you can see now that basically, if you want to understand things, it's not very easy. You may understand it from your view, but somebody else needs a different view of the same thing. Has anybody ever tried documenting an environment formally? Have you ever done that? Yeah. It takes a long time, doesn't it? You always discover something that shouldn't have been done. But what you also then realise is, what happens when I finish doing this? Who's going to keep this up to date? Because actually, if this was important enough to do now, you really should have a process afterwards, which is actually the more important thing. That's what we'll cover next. And these are just different perspectives. In the ITIL framework, the reason I got involved in that was because I ended up working with Lloyds Bank. So they've got 40,000 servers, they have lots of contractors, they have outsourced partners, IBM, Fujitsu, Computer Center, and they were all fighting against each other to blame each other when there was an incident. It's not our problem, it must be theirs. We did nothing, we changed nothing. Yeah, I've heard that one before. But what we ended up doing was we ended up working with their service desk system to use a service map. So these servers support these applications and used by these teams. So when a team says I have a problem, you can then work out what it was likely to be. Which team do I talk to? Is it a Linux team problem? Is it a mainframe problem? Is it a Windows server team problem? Is it a local cabling issue? But actually what we needed to do is we needed quick understanding at the service desk. And so they built this into their service desk systems. So I take it you're familiar with Remedy, ServiceNow, Service Manager, lots of the various tool sets for doing service management and workflow. This effectively is a picture view of what's often in a service desk system. And maybe we might want to simplify things with environments and zones. But the issue there is we have lots of them. So, how do we go forward? Well, the first thing is it's not simple because of the complexity. And as soon as you have more than one building, it's more complex. As soon as you try going across teams, it creates it. So the first thing is, I think you're probably familiar with maturity models, anybody? Where basically, maturity one, we have individuals doing their best, but they're not part of a team. And then the team starts doing things in a consistent way. They support each other, but actually it's not written down. So when somebody new comes into the team, it takes some time before they start learning to do it the same way as others. And then we start defining it, and then we start actually saying, let's write this down, and let's check we even do it. And then the highest level of maturity is you don't even believe you're doing it right. You need somebody else to come in from outside and audit and check, because nobody really wants to say they're not doing things that they should be, that they're breaking the company rules. But you have to have gone through some of those steps beforehand. So everybody can position themselves as part of this. As we go to the right, what we're typically going to be doing is we're starting to embed knowledge in a team system. Just as soon as we start to go here, we start sharing the same spreadsheet. We start doing it the same way. We start using the same conventions and standards. And when we start defining the process, we start separating the roles. And the key thing that I learned years ago was, if you want to control things, you control it at the design stage. Because that's when you're making decisions on architectures, equipments, who's doing what, and what the configurations will be. It's very difficult if you've built something, then try and get control, because you have to go back and reverse engineer. So, centralized design. You may actually have people build, implement, and operate elsewhere, but actually it's as you put things in through your requests and your design. How you plan and manage resource against demand. You need capacity information. But actually, capacity is affected obviously by your policies. You can't put things in that rack, because that's the DMZ rack. Ah, right, but there's space in it. No, build another rack. This is set aside for any management need. We've got physical separation, so we can always drop the power to the outside world if we drop the power to those racks. Right, so that's a quick way to get rid of everything, switch off. But we've actually deliberately designed it with that in mind as policy. And then we have to manage change with cross-team processes. And that's where ITIL, as a service management discipline, was designed and came out many years ago to try and manage complex and risky changes. I use the term infrastructure configuration management. This is really what my job is all about, because there's often different driving points. The first thing is, why do people go and visit the site to see what's in a rack? Why don't you already know what's in there? Well, because there's no documentation they trust. So, people doing this because they just want things to go faster and less cost, and they want to do it because they want to have teams changing, but actually they keep the knowledge within the teams. They want to have less spreadsheets. There's lots of different reasons, but all we have here is just a method, and it's really just common sense. But obviously, don't give it to everybody. But it starts off like this. So the first thing is try and separate out the difference between somebody who plans and somebody who builds. It could be your own team, it could be local teams. And I heard a comment from people that we were talking to last night that actually a lot of the bigger organisations, the multinationals, keep all the control outside of Romania. They may have operations here, but all the decisions are made somewhere else. Says, yeah, that's good. But there comes a point where you also need local autonomy to then be able to say, people will look to themselves first. So actually getting the balance right between central and local autonomy is difficult. But that's often where people start. What you want to try and aim towards is that the infrastructure planning team are actually producing those documents from some form of shared system, typically a database. It could be a service desk, it could be our software, but it's basically something which is better than a spreadsheet. Something that has audit trails, something that can get reports and things out from. But actually, why not have that same shared database also used by operations teams? So what these guys are planning, these guys can see. What these guys are taking out and decommissioning, these guys can see, because there must be change controls for that. But also use the same for your security operations and disaster recovery. So actually, as much as possible, you reduce the amount of data to maintain. Think of the thousands of spreadsheets that people have. I went to one place and they had 2.5 million spreadsheets. Yeah? They had reached the limit of SharePoint. And there was also associated Word documents and recovery plans. And the biggest problem was nobody could find anything. So the first thing wasn't to sort that out. The first thing was to define a naming convention for documents and a directory structure as to where you would find them. So before we do anything, assess and try and build on what already works. And it's the same with our work. We can't necessarily tell you the way to do it. All we can do is guide and advise. Hence the reason why Mihai and Alec are here. Because, one, we don't understand Romanian, but actually, we shouldn't understand your data. Because actually, we will know more about your environment than you will very quickly, because we're putting it in one system. The second step, after we've decided that we're going to do things from a process perspective, and who's going to underpin it, is to then start saying is, why are we really doing this? Let's communicate it to everybody. We're going to start embedding that knowledge. So we don't want individuals to be held personally responsible, we want teams. So we will get lots of benefits. You know, we have this, it's easier to fix faults, because I don't need to wait till somebody comes off holiday, because he's the one that knows how the systems work, because it's in a team system, it's shared, it's used for planning, it's used for operations. So reducing faults and disruptions. But this is normally the reason why people buy this. It's not for security, it's not for cost, because that's not a problem. Normally it's because people are too busy. We have to change because we can't cope. We have to be more efficient and effective. And my advice is always, don't bring in more people if you can make your existing people more productive. Just make it easier for them. Give them some structure. And there's also point number 7 there, which actually still is not very high on people's requirements. It's better for centralised planning, so that you can manage complex changes, but also you can manage your infrastructure should there be an attack or a suspected attack. So, which of these different points, but actually these are all reasons as to why you need to change, or the benefits of changing and adopting these techniques. Now, in practice, it starts with the basics. It sounds very stupid. You just think, it can't be that simple. It says, the first thing you start with is the names of the buildings. Okay? Why? Because you can't start integrating data if you call buildings by different things. And you will end up, probably ending up with a site code or site name, if you haven't already done it. Simple, but you can then go into a level of detail. Let's have names for rooms, let's have this. Because what we want is a unique identifier for everything. So what do we call a port on a switch? So we're going to connect things together. Look at all the variations. This was just from one spreadsheet, where somebody was describing port 1 on the card of a big Cisco switch, on port 1 on card 2. What do we call it? And it was 2/1, 2/1, 201, slot 21, port 21. Do you wonder why you can't integrate your spreadsheets together? Why not have one name, so that then there's a reference? And everybody goes, that would be simple, wouldn't it? I didn't realise they used a different name. So the first thing is, don't do anything without checking and looking first. The aim is to do less work, not more. Everything has a status, so that then you can then say, this is sitting in a rack and it's not being used. This is sitting in a rack and it's in production. This is actually waiting to be installed. So we have to record not just what we have, but what we plan to do. So we're planning to put this in, so the space is already taken up. The switch ports are already allocated. The VLANs are being configured for that. So you can't discover this. You can't use an automatic tool to go and discover it, because we have to record the future. We also have to record that this system is going to be decommissioned. This should not have any new devices on it. There are dependencies, lots of different types of dependencies, which is why we often produce pictures to explain them. And we have processes to check and verify, which is why it's better to centralize the design, because it makes it much easier. In the case of MasterCard, they use our software, so 12 years. Their process is that everything is planned in St. Louis, where any data center or equipment will be right. This is the rack we need to go to. Here's a picture of it. This is a list of all the equipment you're going to be working on. Here's a list of all the connections that we want us to make, and the ones that are already there, so you can check and verify what we've already got. Here is all the cable labels, so that when you actually connect things together, you can add this label to it. So what you're doing there is you're giving good planning documents so that somebody can build it, so that they don't need to remember anything. And you can change providers, you can change staff, you can have flexible rotation. But the key thing is they're managing by actually centralizing the controls. And then when they change their perspectives on security and partitioning and zones, the infrastructure team can work with the security guys, and the security guys said, how does it work at the moment? We need to change it, and they can say, this is how we will change it. These are the things we need to do to get physical and the separation. But the key thing there is, there are processes. There's things they do that, for instance, we could say, I've learned from them. One of the things they do is, whenever they generate a new connection, the label that goes on the cable is a unique number that's composed of the date and the time, anywhere in the world. When they decide to actually remove a connection, they rip the labels off. So by default, they must have a label printer at every site of the same sort, so that then local people who come in don't need to bring any equipment with them. There's a label printer there, and they give them a list that prints off, these are all the labels you need. But their view is, as soon as you take the cable out, you rip the labels off, and therefore you never reuse or have to track the labels of cables. The benefit they got from that is each month you can actually say how many connections have been made and on which site just by looking at the numbers. So it's done by year, month and a number. Okay. So we start getting into naming conventions, which is the first starting point. I'll speak to somebody about auditing and governance, and one of the first things that any outsider looks and says, why do you do it so differently? Why do you present information badly to me? Why don't you guys talk to each other? Why not simplify? Could you show me that, here's a network diagram of a key component. Could you show me where it is in all the rack diagrams? I have no idea. Don't know how to find it. Right, so is it in the same rack as any of these other components? Because here you've got a big red box around it saying this is separate. No, but these are in the same rack. So anybody working on that works on this. So it's not really separate. So we standardise our naming conventions. It also applies to your symbols, your pictures. I ask people, how many people have a standard Visio template for doing diagrams in their organisation? Everybody goes, didn't ever thought of that. Do you have a standard Word document template for doing letters? Yeah. Why don't you have a standard Visio template for doing IT diagrams? Never thought. That's why every diagram is different. It's actually quite simple when you think about it, but a lot of this is simplification. Introduce lots of outputs from a few sources. And that's effectively what our software does. We have a database and it just produces them for you. So you don't draw them. So that's the way we automate things. That's the ultimate. But you don't necessarily have to use that. There are other techniques and ways. But as much as possible, reduce the numbers of sources to maintain. So when we start looking at this, when we go back to this diagram, the way we would approach that is, I wouldn't go and start tracing the cables. I would start saying, what are we going to call the rack? What are we going to call the equipment in the rack? When we start tracing the cables, we're going to be tracing them between the things we've already got names for. So you do it in a structured approach. If we're doing a data center, the first thing we do is a floor plan. Because actually we may need to give names to racks to start with. The next step is define your own best practice. So who does what? This is a process thing, it's a handover from design to build quite often. But just as a simple thing, this is a set of optical cassettes. Okay? Common in data centers now to give lots of connectivity. So what you want to do is connect to cassette number 5. So is number 5 starting from the bottom or starting from the top? Does it sound simple? Go and have a look and see how people make things. Because if we have a rack of equipment, is position 1 at the bottom or the top? And you're just looking and go, how could people make such simple things? Because they're making a decision, they don't know what anybody else has done. And so that's why you need some rules and standards. In the vast majority of cases, we find it inconsistent. When I worked with Alec in Saudi Arabia, he had lots of racks, and I think it was a top-down naming, wasn't it? So position 1 was at the top, and some racks got delivered that started number 1 at the bottom. So what do? You send them back, or do you put a label over them starting at the top? And the reason is we want it to be simple. So simple is good, because we need to control the simple stuff first. Also, what are we going to call the cassette? So when we start putting it into our spreadsheet or database, do we call it cassette 5? Or cassette 5 in optical distribution frame 3? Or is it cassette 5 in rack A05? Or in hall A of the data center? Or in data center 1? Or in Dubai data center 1? So what are you going to call it? Because if you don't know what you would call it, neither does anybody else. So you're not going to get good entry into your systems. So with infrastructure configuration management, we may end up with long names like this to uniquely identify everything. But there are no mistakes. If you don't do this, you'll find that there's 2 optical distribution frames in the same room. there's 2 rack number 1s, there's 2 of this, and somebody takes the wrong cable out. So all your security procedures and controls, all of your processes are all compromised by the fact you've got 2 things with the same name. And you look and you go, what's the point? You've tried to leapfrog doing the basics, and actually you're now suffering for it. As you can see, I get very busy. Normally our organisation, we don't do audits. We give you the tools, we give you the methods, but you should use your own people, you should use your contractors, you should use the people who know how to get in there to actually gather information, put it all together. But occasionally we do get involved in doing audits. And in every single case, even with what I'm doing at BT, I've recommended they relabel lots of their cabinets, all 6,500 of them. Is why? Because you've got one method in that data centre, one in that method. Individual people, when you're trying to work centrally, who work across those data centres, get confused. Even things like, a lot of these data centres, there's 5 or 6 data halls. Once you're in them, you don't understand which one you're in, because they all look the same. You know, you're looking at a rack, and you've forgotten which room you're in. You may say like that, but actually with all the noise and all the confusion and phone calls and things like that, just one system. It ran on all those different servers, and used those different firewalls, and they wanted to understand interdependencies. Okay? Okay. And there was about 80 odd servers there, out of 40,000. So, how long did it take to do that? 2 minutes. They tried doing it themselves for a month, and I said, you're interpreting your service-based system differently. Why don't you just put it in and draw it? But understand, when you make a change to something in a rack or a system, you add a server, you take it away, you move it onto a cloud, some or all of these different types of things that people currently maintain will probably change. So if we put it into a rack, we should put it into an inventory list. We should put it into a diagram. We should connect it up and put it into a spreadsheet. We should change the capacity of the rack from a power perspective. You can see how many different duplications. Why don't we have one name for everything, and we use that name in every source of information we use? Anybody disagree? Sounds like simple? Yeah. Why do I have to come here to explain something simple? The reason is because you probably have to go outside and explain to someone else that simple is better. It is less work, not more work. But it does mean organising, and it does mean having focus. Of course, the bigger the environment, the more there is. I have one customer with over 100,000 servers. They think, and they want to do a cloud migration. And they're not sure what to migrate, because they're not sure what things do, and they're not sure of the risks. There are a couple of organisations in the US, and if you go onto our SquareMile website, you'll see various webinars, and one of them is from a company called David Kennett's group. They specialise in data centre migration planning. That's all they do. And they give a price to a customer on the basis of what they think the customer will pay. Okay? Not anything else. They don't believe anything the customer gives them, so they collect data, they don't go and check it themselves. They use our software, which is how I know all of this stuff. They put it into our software. And then they tell the customer actually how this network really works, but also how they're going to migrate. But they will guarantee there will be no service disruption to any of their IT systems as part of their planning. And the customer goes, I can't do that on a daily basis with my existing IT team. They're going, yeah, so we will guarantee it. You can sue us if anything goes wrong. But we only deal with migrations greater than 5,000 servers. If it's less than that, we don't care. And as long as it's 5,000 or more, we know that it's so complex you don't understand it, and we're going to have a team working for a year doing this. But it may cost $20 million. Well, what are you going to do for $20 million? You don't need to know, it's our problem. Yeah, but you could do it with less time. Well, you do it then. Okay? But they have this attitude, they know their business. But there is a scale in America that's a bit different. So, but you're going to have to be handling this, as well as this, when you come down to doing security assessments. Where's the information? And if you start gathering and collecting it yourself, aren't you now creating your own spreadsheets? The answer is yes. And then the last step there is to also start, as well as you're developing and bringing in data, to start thinking about how you streamline the interface between teams So you maintain the information and you maintain the understanding. Because security doesn't stop tomorrow. It's forever. When I talk to customers with our software, they often talk about when can we start. And I actually say, that's interesting. This is why. When do you want to finish? Yeah, because normally when you plan a journey, you think about when do I need to be at the airport, because the plane takes off. That determines how I start now, and whether I go by car, I walk, or whatever. I hadn't thought of that. So, do you want this done in 6 months, 1 year, 2 years? I don't know. Well, think like that, because this isn't going to go away. How long do you intend to keep using our software? I hadn't thought about that. Forever? Probably, because you can't go back to spreadsheets. So think about this in a very deliberate way. This isn't something that you want to start and then give up on, because otherwise there's no point. But also when you're hacked, you then realise, I wish we'd done this a year ago. And the danger signs, just to finish now, the danger signs for complexity management and your understanding, these are the things that I always see when I'm talking with people. You're changing, any changes in staff, changing outsource, contractors. A lot of people in Europe are all reducing the amount of temporary staff and contractors and trying to reduce costs and just use their own teams. And those contractors are just walking out the door. A Dutch bank I'm working in, 80% of the IT staff are contractors. The costs are huge. And they've said as a policy they're getting rid of them. The same with the Amsterdam government I did many years ago. They had lots and lots of contractors for the skills. The trouble was, they were still around. They've been there for 10 years. So anything that loses knowledge, you need to capture it, because you want an institutional knowledge base. Any inconsistencies, if I see things that are different, I know there's going to be confusion. I can spot it. It's my world. And I can see things in spreadsheets you probably can't. And I'll notice things. And from that evidence, I can then predict behaviour. When you get to somebody, I bet you find that's not in, you're not sure if it's in the rack. Because why? Well, you don't say whether it's in the front or the back. That's the point. It doesn't say that, does it? No. So when somebody's planning, they're not sure if the patch panel's in the back or the front. With server racks, it's probably in the back. With network racks, it's probably in the front. But you don't describe this. No. It's a shame. If you had that, it would have been useful. Because we don't have that, you have to go and do an on-site audit. Ah, right. Oh, there's 2 patch panels, one in the back and the front. Ah, good. Which one? Any communication barriers, teams that don't want to talk to others. Outsourcing, because that forms a communication barrier, contractually. We have a major problem in England with our Ministry of Defence. They outsourced 10 years ago to various IT service providers, many of the ones that were hacked earlier on today, HP, Fujitsu, and others, and they're getting poor service. It's all public, it's not sensitive, but they're stopping those outsourcing contracts and they're trying to insource. And the outsourcers are not helping, saying, if we help you, it does us out of the job. So who do they go to? Because they have to now gather the knowledge of the whole military infrastructure, because the outsourcers don't want to help them. So they're trying to get the people, and they're trying to bring them in-house. But nobody wants to wear a British Army uniform if you're an IT person, or to do a battle test where you have to run 2 kilometres in full gear. They're employing military people to do IT work, but that's nice. And the other one here is ownership and assertion. If you see people doing things wrong, can you get them to just even do it the right way? And if they ignore you, you've got a problem. Because actually it means your policies aren't being implemented. You can't trust them. And that was the session, the whole thing about today is how do you trust things? And you can trust things if you trust the people and the processes and you see the evidence of that. But realise it is not easy. You have to actually often change the way you work. And in my case, it helps if actually you simplify the documentation of how everything works as well, as part of that. So our approach is basically to take the different sort of layers. This is often an approach that people describe everywhere from the non-technical physical infrastructure all the way up to what underpins the business processes. Is to take that infrastructure and bring that into a database. What we found in practice is not easy to do. So although we have one database, we have 2 different front ends. One for technical guys doing physical information down at the bottom layers, which we call our Connect system for doing connectivity and inventory. And then this system called SysMap is a very flexible way to describe virtual systems, clustering, applications, servers, things you can't touch. So if you had only a cloud infrastructure, then SysMap. If you want to do a university in every single cable and connection across all the buildings, you use Connect. But from that database, you then produce different outputs. It could be summaries, capacity, change management. And the bit that most people know us for is it produces things you can send to people, a physio diagram of a rack. It takes about 10 seconds to do a rack diagram. Normally it takes about 2 hours. So if you start thinking, so if I've got 100 racks to do, 100 racks, probably do 4 or 5 a day, could do 5 a day. Start doing the maths. 20 days worth of work to do 100 racks, or 15 minutes. Which is best? How do you get 100 racks drawn consistently by the same person, never mind by different people, because they'll change their method, or do you want in 15 minutes they'll all be done? So a lot of this is about simple things. It's just a quicker way. It's a technology issue. But you still need a Visio standard, so they're all the same as part of that. But I'm not going to cover any of this. I just wanted to be aware there is information about it, and I'll cover this a bit more this afternoon if anybody wants to, as part of Visio automation. And I hope that's been useful for yourselves, that you've understood that actually, what does understanding an environment mean? It means a lot of work, but probably you work too hard anyway. You see customers, you see people in your own organisation, you see people working, doing things which actually never been maintained. Yes, it ticks a box and says we're compliant with something, but actually it's never going to be compliant the week after, or anything like that. And I hope what you've learned is you've understood that there are best practices in this area. Just learn, adopt. I put materials on the web, but there's also lots of others. But there's actually a lot of infrastructure out there, and not many people understand how it works, even in Romania. But it's the same in England, the same in France, it's everywhere the same. I do airports, hospitals, at the moment in the US we have Disney Television, 2 major hospitals, Department of Homeland Security, Department of Agriculture, New York City, and they're just the current ones at the moment, you say, which are new things that are happening. There's all the legacy stuff. Could be health insurance, banks, doesn't really matter. They're all using the same systems, and I hope that gives you an understanding. I think we've just tea time now, but I'm not sure that there's any questions on that, just quickly. Probably thrown too many things in your brain. And speaking English too quickly. But let's talk over the break. Jochen's going to be covering later on about the issues around partitioning and separating out domains and things with some of this stuff. And obviously we've got lunch as well. Okay, what time do you want to start, Alec? We start?
Yes, I think we think. Thank you very much, David, for the presentation, and we will take a short break for some drinks, and then we will go to a bit shorter part presented by Jochen. I want to mention myself that you have in the folder also a questionnaire, a feedback form. You might wish to put your rating, and we'll be very happy. We'll have a draw for the Google Home Mini for the people who have submitted this form. So please, we will have a short recess, so literally quarter of an hour. Thank you very much.